This video will go over fundamental identities, even and odd identities, as well as verifying identities. So we're going to begin with fundamental identities that we already know, and they are found on the back of your unit circle. Those are our reciprocal ones, our quotient ones, and our Pythagorean ones. For an even function, we say algebraically that it means that we have f of x, the y value when we plug in x, is the same y value if we would have plugged in negative x into our function. So I'm going to write that down. That means we have the same y values for our negative x value. Graphically, it would mean that we would have something like our positive theta and a negative theta, and we would get the same value when we're done. In this case, we would get the same cosine. So this value would still be the same right here, whether we plugged in a positive theta or a negative theta. So that means that we just found that cosine of theta is the same thing as cosine of negative theta. This also works for secant of theta. It's the same thing as the secant of a negative theta. So those two are considered even functions. The other one is an odd function. And that's when we have our f of x. If we plug in a negative x value for our function, we actually end up getting a negative. So in other words, we get a negative y value for our negative x value that we plugged in. Now, what does that mean in terms of graphically? Well, again, we're going to have our angle theta, and we notice that it's going to give me a positive value. And if I have a negative theta, it's going to give me a negative value. So we can see that we have one up here as a positive value, and the one down here is a negative value. So we can see that that happens for sine of our angle. So sine of theta will give me this part, and sine of negative theta will give me this part. So we find that sine of theta is equal to the negative sine of negative theta. Now maybe we can also see this as sine of negative theta is equal to negative sine theta. They both say the same thing. So we see this happening for both sine as well as cosecant of theta is equal to negative cosecant of negative theta. This also works for tangent. Tangent of theta is equal to a negative tangent of negative theta. And this also works for cotangent. Cotangent of theta is equal to negative cotangent of negative theta. And the reason why it works for all of these is because all of these contain sine of theta. So all of those will be odd. Now let's try an example. Let's say we have example number 1 that says if tangent of theta is equal to a negative 5/3 and theta is in the second quadrant. So I just want to remind you that what we do is we think of it over here in our second quadrant. Here is theta. We know that tangent is the rise, which was 5, and 3 is the run. And we can see by its position that the 3 is negative. And we know that our tangent is going to be a positive 5 over a negative 3. And then the question is, how do we find secant? This should be an A. How do we find secant, sine, and cotangent of my angle? So what we do need to remember is how to get our hypotenuse. Remember, we get this value up here. I'm going to call it x for right now. That 5 squared plus a negative 3 squared is equal to x squared. So that's going to be 25 plus 9 is equal to x squared. X squared is equal to 34. So x is equal to the square root of 34. So we can change this to the square root of 34. Alright, based on that, if we want to know what secant is, remember secant of theta is the same thing as 1 over cosine of theta, or the reciprocal of cosine of theta. So we can see from our triangle that cosine of theta is equal to the adjacent over the hypotenuse. That's going to be negative 3 over the square root of 34. Before rationalizing that, realize that I'm looking for secant. So I need the reciprocal of that. So secant of theta is equal to negative square root of 34 over 3. So there was no need to rationalize the denominator because it actually became the numerator. So let's go find sine of theta. So remember, for sine of theta, that's going to be the opposite side over the hypotenuse. That's going to be 5 over the square root of 34. In this case, there is no flipping around, so we are going to rationalize the denominator. So I have 5 over the square root of 34 multiplied by the square root of 34 over the square root of 34. And I find that this is going to be 5 square root of 34 over 34. 34, I think, is 2 times 17, so we cannot simplify that. So we have found sine of theta to equal to this value. And last but not least is to find cotangent of negative theta. So let's go find tangent of negative theta. Well, what we found out up here when we were talking about even and odd functions is that tangent of negative theta. So what we found here is that tangent of theta can equal to tangent of negative theta, and then it has to have a negative somewhere. So I'm going to put it over here. So that means what I can do is, because of this guy right here, I'm going to change this to negative tangent of theta. So I got to go find this, and then I'm going to go find the reciprocal of that. So I can find cotangent of negative theta. So looking back at our graph, we see that tangent of theta is given as negative 5 over 3. So I see that this is going to be negative 5 over 3 is our tangent of theta. Then I need to put a negative on the outside. It's going to be positive. Now I'm looking for the cotangent. So I'm going to find that the cotangent of negative theta is going to equal to the reciprocal of this, which is 3 over 5. And that finishes up example number 1. So for page 71, I want you to print out this particular handout and tape it onto page 71. These are helpful hints for verifying identities. So that's the next thing that we're going to talk about. So I want to highlight a couple of things here. One of the things it says for us to do is to learn our fundamental identities. And the big ones to think about are your Pythagorean sine squared plus cosine squared is equal to 1, as well as different ways of writing that same one. The other thing is to rewrite the more complicated side of our equation. So if you can look at one side and say, oh, I can do something, that's the side you want to start with. Number 3 says it is sometimes helpful to express functions in the equation in terms of sine and cosine. Sometimes when you have tangent or cotangent, maybe if we simplify it into sine over cosine or cosine over sine, it helps simplify our expression. The fourth one is usually any factoring or indicated algebraic operations should be performed. So for example, we can see our factoring guys that we talked about in our review. Notice we did these 3, but the others 2 about difference in sums of cubes can also be seen in our verifying identities, but maybe not as often as the other ones. And main thing here is that we may not be seeing a squared and x squared and y squared, but what we will be seeing more so is going to be like sine squared of x plus 2 sine of x plus 1 that needs to be factored using our factored forms. Another thing that we're going to see is going to be maybe having to add and subtract fractions, and then similar, that's why we were doing that in the review. In this case, we have fractions that we need to add that have two different denominators. So notice I'm going to get the common denominator of sine theta cosine theta and create the same denominators, so that once I have the same denominator, all I have to do is add the numerators. And here's an example of what we did in the review. For number 5, it says when selecting substitution, keep in mind the side that is not changing because it represents our goal. So in other words, when we want to simplify one side, we want to keep the other one the same, and so we know where we want to go. So again, the best way of doing verifying identities is to practice and just keep doing them. And the last one is if the expression is 1 plus x, try multiplying the numerator or the denominator by its conjugate 1 minus sine of x. And that will give you 1 minus sine squared of x, which means we can use our Pythagorean identity and realize that that's cosine squared. So again, make sure that you trim this and put it on page 71. On page 72, let's do some examples of verifying identities. So from here, we can see our job is to verify this fraction over here is the same thing as negative secant squared of theta. So I always start off with asking myself which side is the ugly side, and we can clearly see that the left side is probably our ugly side. So let's rewrite that one as 1 plus cotangent squared of theta over 1 minus cosecant squared of theta. And remember, we want to manipulate this side until we make it look like the other side. So one of the strategies they said is that if you don't know where to start, maybe you can start writing everything in terms of sine and cosine. So I'm going to rewrite this as 1 plus cosine squared of theta over sine squared of theta. Remember, that's the same thing as cotangent squared of theta. And at the bottom, I'm going to have 1 minus 1 over sine squared of theta. That's our definition of cosecant squared of theta. So now I have made it worse. Now I have fractions inside of fractions. But what I'm going to do is I'm going to multiply the numerator by sine squared of theta. And I'm going to multiply the denominator by sine squared of theta. Notice what I'm doing is I'm actually just multiplying by a magical 1 is what I call it. So I'm going to write that down, that we change the way we write cotangent squared and cosecant squared by using sine and cosine. So we just rewrote it. So rewrite with sine and cosine. And then what we did here is we're multiplying by a magical 1. And I call it magical because it changes on the scenario. So now I'm going to do distributive property. I'm going to do sine squared theta times 1 is sine squared theta. And sine squared theta times this fraction right here is going to give me plus cosine squared of theta. At the bottom, I'm going to multiply sine squared times 1, so I get sine squared of theta. And then I'm going to multiply sine squared times this guy. I'm going to have minus 1. Alright, so we've done that. Now let's use some of our identities. This one should stand out. We know that that's equal to 1. So that's one of our identities. And then we need to figure out this one. This one looks suspicious. So let's see if we can figure that one. So what we have in the numerator is 1, because sine squared plus cosine squared is equal to 1. At the bottom, I have sine squared of theta minus 1. But again, remember we had sine squared plus cosine squared is equal to 1. I need sine squared minus 1, so sine squared, I'm going to put the 1 over here. which means I'm going to bring this guy over here. So I'm going to have negative cosine squared of theta. So what does that mean to us? That means this is going to be 1 over negative cosine squared of theta. So my negative is in the denominator. I'm going to bring it out to the front. So then I have negative 1 over cosine squared of theta. And we know that is another identity. This is another ID. That's going to be our reciprocal identification, which means this is the same thing as negative secant squared of theta. And that is exactly what we were actually looking for. Let's try example number 3, which our job is to verify that tangent squared of theta times the quantity of 1 plus cotangent squared of theta is equal to 1 over 1 minus sine squared of theta. So pick an ugly side. I'm going to pick the left, and I'm going to rewrite that as tangent squared of theta 1 plus cotangent squared of theta. And the reason why I chose this side is that I can quickly see that I can use the distributive property and do something. So I'm going to do that, and I'm going to get tangent squared of theta plus, now what happens when I multiply tangent squared of theta times cotangent squared of theta? Well, remember this is the same thing as 1 over tangent squared of theta times our tangent squared of theta. Fractions only do it with other fractions, and I think you can see that I'm going to get tangent squared at the top, and I'm going to get tangent squared at the bottom, and that's equal to 1. Cool, so we have figured that one out. Now, notice I have a fraction on the left side, so I need to create some fractions for our guy too. So I'm going to rewrite tangent squared as sine squared of theta over cosine squared of theta. Still plus 1. Now if we have fractions, remember fractions do it with other fractions, and then more importantly, we want to get the common denominator. So I'm going to multiply the 1 times cosine squared of theta over cosine squared of theta. Remember, we're multiplying by our magical 1 here. So when I do that, the first fraction stays the same as sine squared of theta over cosine squared of theta plus cosine squared of theta over cosine squared of theta. Since I have the same denominator, I can write it as sine squared plus cosine squared. And then that's an identity that we should recognize. Told you we would see this guy over and over again. So that's going to give me 1 over cosine squared of theta. Well, we have the 1 over, but how are we going to get that 1 minus sine squared? Well, we're going to go back to our Pythagorean identity that says sine squared plus cosine squared is equal to 1. I want cosine squared because I want to change the name of it. So I'm going to subtract sine squared to both sides. So that means I can write this as 1 over, and then instead of writing cosine squared theta, I'm going to write 1 minus sine squared theta. And that's exactly what we were looking for. On page 73, let's continue verifying some more identities. We need to pick a side, and in this one I think they're both equally ugly, so we just need to pick one. I'm just going to go ahead and pick the left side here. So we're going to start off with that, cosine of x over 1 minus sine of x. And if we go back to page 71, we had the hint that said that if you had something that looked like 1 minus sine of x, try multiplying it times its conjugate, 1 plus sine of x. So we'll do that at the bottom as well as at the top. And again, you can see that I'm multiplying by a magical 1. At the top, I'm going to do the distributive property, and I'm going to get cosine of x plus cosine of x sine of x. In the bottom, I'm going to do FOIL and find 1 minus, so that's 1 times 1. Notice on the inside I'm at negative sine of x, positive sine of x, so they're going to cancel out. And then I'm going to multiply my two sines, so I'm going to get negative sine squared of x. Then we can probably recognize that this guy right here is from our Pythagorean identity of sine squared plus cosine squared is equal to 1. I have 1 minus sine squared. That means that's equal to cosine squared. So we'll rewrite that. So this becomes cosine of x. And I'm going to undo my multiplication, 1 plus sine of x. So essentially, I went, instead of doing this part, I came back and rewrote this guy. You'll see why in just a second. At the bottom, we said we were going to rewrite this as cosine squared of x. So we can see that cosine of x, 1 plus sine of x, and again we should have looked a little bit on the right side and noticed that we want to keep it as 1 plus sine of x. And notice I can rewrite my cosine squared as cosine of x times cosine of x. And now we can see that these will factor out, and what we're left with is 1 plus sine of x over cosine of x, which is what we were looking for. Let's try example number 5. For this one, we need to pick an ugly side and see which one we think is uglier. Now, I like to pick the left side to be ugly, only because I know that one of the first things I can do is rewrite those in terms of sine and cosine. So, for example, if we have secant of x plus tangent of x, I know I can rewrite that as 1 over cosine of x plus sine of x over cosine of x. And the denominator, which is secant of x minus tan of x, again I can rewrite that as 1 over cosine of x minus sine of x over cosine of x. Now I've made it worse, it looks like, but everybody has a denominator of cosine x, so I'm going to multiply by cosine x at the top and multiply by cosine of x at the bottom. Remember, I'm actually multiplying by a magical 1. I'm going to use a distributor property here, and I'm going to use a distributor property down here. When I do that, we're going to get 1 plus sine of x. At the bottom, we're going to get 1 minus sine of x. And notice that up here, we have 1 plus 2 sine of x plus sine squared of x. So what I'm going to do is again multiply by a magical 1, and that's going to be, let's see, I want sine squared plus 2. So I'm going to do 1 plus sine of x at the top, and I have to do 1 plus sine of x at the bottom. And now I'm going to do FOIL at the top and FOIL at the bottom. That's going to give me 1. That's going to give me plus sine squared of x. On the inside, it's going to give me sine of x and another sine of x. That's 2 sine of x. At the bottom, we're going to find it's going to give me 1, because 1 times 1 is 1. And then I'm going to get sine of x times sine of x is minus sine squared of x. And then on the inside, I'm going to get negative sine of x and a positive sine of x. So they actually cancel each other out. And I think you can probably see from here that I can rearrange these guys to come up with this numerator that we have right here. So I'm going to do that. So that's going to give me 1 plus 2 sine of x plus sine squared of x. And in the bottom, notice that's going to be our other identity. Remember, sine squared plus cosine squared is equal to 1. I have 1 minus sine squared. So that's the same thing as cosine squared of x. And that is what we were looking for. So let's go to page 74 and do our last example for the lecture. We're going to start off on the left side because at least I know I can use my quotient rules to change this one. We have tangent of x minus cotangent of x over sine of x, cosine of x. Now one of the things we can do is notice that we have these separated. So why don't we separate our fraction and write this as tangent of x over our denominator minus cotangent of x over the same denominator. And since I already have everything in terms of sine and cosine in the denominator, let's do the same thing in the numerator. So I'm going to change tangent to sine x over cosine x, and I still have my sine x cosine x at the bottom, minus, and then I'm going to change my cotangent to cosine x over sine x, same denominator, sine x cosine x. So I'm going to get rid of those fractions inside of a fraction, so I'm going to multiply this one by cosine x, but if I do it at the top, I got to do it at the bottom. And I'm going to do the same thing over here, but I'm going to multiply by sine of x. But if I do it at the top, I got to do it at the bottom. Doing our multiplication, we're going to find that I get sine of x at the top, and at the bottom I get sine of x cosine squared of x. For the second fraction, my sines cancel and I end up with cosine of x. And at the bottom I end up with sine squared of x times cosine of x. Now I did that so that we can see that I can factor out stuff. Now remember, fractions can't go around topless, so I actually have ones right here. So this now looks like 1 over cosine squared of x, which means we know a name for that. That's secant squared of x, minus 1 over sine squared of x, and that is cosecant squared of x. And if I'm not mistaken, that's exactly what we were looking for. So that concludes this video.